Blood moon. The Earth's atmosphere refracts and filters sunlight to favor the redder wavelengths, which then fall on the moon to make it appear orange or blood red during a lunar eclipse. Sunlight bends and scatters as it passes through Earth's atmosphere. In air, colors at the blue and violet end of the rainbow scatter more widely than colors like red and orange. Widely scattered blue light tints the sky when the sun is overhead on clear days. Redder light travels a straighter path through the air. We only see it scattered throughout the sky around sunrise and sunset, when sunlight has traveled through a thick slice of Earth's atmosphere before reaching our eyes. During a lunar eclipse, some of this heavily filtered morning and evening light makes it all the way through Earth's atmosphere and eventually reaches the lunar surface. The eclipsed moon is dimly illuminated by red-orange light left over from all of the sunsets and sunrises occurring around the world at that time. The more dust or clouds in Earth's atmosphere during the eclipse, the redder the moon will appear. Blue moon. A blue moon is an additional full moon that appears in a subdivision of a year, either the third of 4 full moons in a season, or a second full moon in a month of the common calendar. The phrase has nothing to do with the actual color of the moon, although a literal blue moon, the moon appearing with a tinge of blue, may occur in certain atmospheric conditions. Example, if volcanic eruptions or fires leave particles in the atmosphere of just the right size to preferentially scatter red light. Blue moon, is there really such a thing? The saying, once in a blue moon, has nothing to do with color. Instead, it refers to the relatively rare occurrence of what is called a blue moon. However, an actual blue-colored moon could occur from atmospheric effects such as a big forest fire on Earth causing a lot of haze. This has happened in the past. The definition of a blue moon has changed over the years. However, the commonly accepted definition of a blue moon is simple: it is a full moon that rises twice in 1 month. It happens because sometimes the number of days in a calendar month are greater than the cycle of the moon, which is 29.5 days. This can cause the moon to rise twice in 1 month, near the first and the last days of the same month. It is said that blue moons happen every 33 months or about every 3 years. This relatively rare occurrence has spawned the saying, once in a blue moon. Supermoon. A supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit, a point known as perigee. During every 27-day orbit around Earth, the moon reaches both its perigee, about 226,000 miles, 363,300 kilometers, from Earth, and its farthest point, or apogee, about 251,000 miles, 405,500 kilometers, from Earth. Supermoon isn't an official astronomical term, but typically it's used to describe a full moon that comes within at least 90% of perigee. The term was coined by astrologer Richard Knoll over 30 years ago. Supermoons only happen 3 to 4 times a year, and always appear consecutively. Throughout most of Earth's orbit around the Sun, perigee and the full moon do not overlap. Traditional full moon names. For millennia, humans have used the movement of the moon to keep track of the passing year and set schedules for hunting, planting, and harvesting. Ancient cultures the world over have given these full moons names based on the behavior of the plants, animals, or weather during that month. These names come from Native American, Colonial American, or other traditional North American sources passed down through generations. January. Wolf moon. The howling of wolves was often heard at this time of year. Many sources state that wolves howl due to hunger. Rather, wolves use howls to define territory, locate pack members, reinforce social bonds, and gather for hunting. February. Snow moon. February is typically a time of heavy snowfall. March. Worm Moon. Traditionally thought to be named after the earthworms of warming spring soil. Alternatively, in the late 1700s, Jonathan Carver wrote that this moon actually refers to a different sort of worm larvae, which emerge from the bark of trees and other winter hideouts around this time. April. Pink Moon. This full moon heralded the appearance of the moss pink, or wild ground phlox, one of the first spring wildflowers. May. Flower Moon. Flowers spring forth in abundance this month. June. Strawberry Moon. This was the time to gather ripening strawberries in what is now the northeastern United States. July. Buck Moon. At this time, a buck's, male deer's, antlers are in full growth mode. August. Sturgeon Moon. The sturgeon of the Great Lakes and Lake Champlain were said to be most readily caught during this full moon. September. Harvest Moon, or Corn Moon. The full moon that occurs closest to the September equinox. This time also corresponds with the traditional harvesting of corn. October. Hunter's Moon. This is the month when the game is fattened up for winter. Now is the time for hunting and laying in a store of provisions for the long months ahead. November. Beaver Moon. This was the time when beavers finished preparations for winter and retreated into their lodges. December. Cold Moon. This is the month when the winter cold fastens its grip and the nights become long and dark. Moon Illusion. Why does the moon look so big when it's rising or setting? The moon illusion is the name for this trick our brains play on us. Photographs prove that the moon is the same width near the horizon as when it's high in the sky, but that's not what we perceive with our eyes. Thus it's an illusion rooted in the way our brains process visual information. Even though we've been observing it for thousands of years, there's still not a satisfying scientific explanation for exactly why we see it. When we observe the moon near the horizon, it often looks huge, whether it's peeking over the shoulder of a distant mountain, rising out of the sea, hovering behind a cityscape, or looming over a thicket of trees. But here's the thing, it's all in your head. The moon's seeming bigness is an actual illusion, rather than an effect of our atmosphere or some other physics. Why do we see the moon illusion? We don't really know. Well, not really. Depending on your mindset, this news might be unsatisfying, or it could be a reason to marvel at our mysterious brains. But despite the fact that people have been observing this illusion for thousands of years, we still don't have a rock-solid scientific explanation for it. In general, the proposed explanations have to do with a couple of key elements of how we visually perceive the world, how our brains perceive the size of objects that are nearer or farther away, and how far away we expect objects to be when they're close to the horizon. It seems that our brains don't know that the moon's distance doesn't change that much no matter where it is in the sky on a given night. There's also some thinking that objects in the foreground of your lunar view play a role. Perhaps trees, mountains, and buildings help to trick your brain into thinking the moon is both closer and bigger than it is. There's an effect discovered a century ago called the Ponzo illusion that describes how this works. In the illusion, you have a scene where two lines are converging, like railroad tracks stretching away into the distance. On top of these lines are drawn two horizontal bars of equal length. Surprisingly, the horizontal bars appear to be different sizes, because your brain's hardwired sense of how distance works forces you to perceive it this way. This effect is related to how forced perspective works in paintings. But this isn't a perfect explanation either. NASA astronauts in orbit also see the moon illusion, and they have no foreground objects to act as distance clues. So, there's likely more going on. Eclipses. Anywhere from 4 to 7 times a year, our Earth, Moon and Sun line up just right to create the cosmic scale shadow show known as an eclipse. The Moon's orbit around Earth is tilted relative to Earth's orbit around the Sun. This tilt is the reason why we have occasional eclipses instead of eclipses every month. There are two types of eclipses, lunar and solar. During a lunar eclipse, Earth's shadow obscures the Moon. During a solar eclipse, the Moon blocks the Sun from view. Lunar eclipses occur at the full moon phase. When Earth is positioned precisely between the Moon and Sun, Earth's shadow falls upon the surface of the Moon, dimming it and sometimes turning the lunar surface a striking red over the course of a few hours. Each lunar eclipse is visible from half of Earth. Solar eclipses happen only at the new moon phase, when the Moon is between Earth and the Sun. During a solar eclipse, the Moon casts a shadow on Earth, and blocks or partially blocks our view of the Sun. Though solar eclipses happen as often as lunar eclipses, they are visible from such a small area of Earth each time that it's much rarer to encounter one. Tides. These animations help to explain the science behind how the Moon affects the tides on Earth. The Moon and Earth exert a gravitational pull on each other. On Earth, the Moon's gravitational pull causes the oceans to bulge out on both the side closest to the Moon and the side farthest from the Moon. These bulges create high tides. The low points are where low tides occur. The Moon's gravitational pull on Earth, combined with other, tangential forces, causes Earth's water to be redistributed, ultimately creating bulges of water on the side closest to the Moon and the side farthest from the Moon. Rising and ebbing tides happen as Earth's land masses rotate through the tidal bulges created by the Moon's gravitational pull. Our observer sees the tides rise when passing through the bulges, and fall when passing through the low points. Of course, in reality the Earth isn't a smooth ball, so tides are also affected by the presence of continents, the shape of the Earth, the depth of the ocean in different locations, and more. The timing and heights of the tide near you will be affected by those additional elements. Twice a month, when the Earth, Sun, and Moon line up, their gravitational power combines to make exceptionally high tides, called spring tides, as well as very low tides where the water has been displaced. When the Sun is at a right angle to the Moon, moderate tides, called neap tides, result. From our view on Earth, these tides coincide with certain lunar phases since they occur when the Moon reaches specific positions in its orbit. Earth's tidal bulges don't line up exactly with the Moon's position. Because the Moon is orbiting in the same direction as the Earth rotates, it takes extra time for any point on our planet to rotate and reach exactly below the Moon. This means that the high tide bulges are never directly lined up with the Moon, but a little behind it. Lunar near side major craters. Some major craters on the Moon near side. lunar near-side Major Maria. The moon is our nearest neighbor, our nightlight. It's also our memory. While wind, water, and molten rock erase Earth's deep history, the moon remembers everything that has happened in the last 4.5 billion years. The impact that formed the Oriental Basin provides a window to understanding how similar large events on other planets and moons have shaped their landscapes. The discovery of water on the sunlit surface of Clavius crater not only unlocks new possibilities for future lunar exploration, but also our understanding of where the ingredients of life could exist in our vast universe. The steep trenches and cracked surface of Komarov crater on the far side tell a story of the ancient volcanic activity from the moon's interior, revealing the history of geological forces carving the lunar terrain through time. Traversing the landscape, we can see a beautiful tapestry of ridges, valleys and mountains, best encapsulated by the view of Ctto crater. The summit of its central peak stands nearly 3 miles above the crater floor, a visual metaphor for the steep challenges but exciting rewards that await us on the moon and beyond. And on the lunar horizon, the most consequential view of all, our home. To study the moon is to study ourselves, our past, our present, and our future, each new discovery bringing us from darkness into light. The gravitational forces between the Earth and Moon make our very existence possible, creating one of the most special relationships throughout time and space.